Now you see. Next we did sampling. In the sampling, we have covered how many categories? We covered first category of single proportion. Single proportion. After this, we did difference of proportion. Difference of proportion. After this, we did single mean. After single mean, we did difference of mean. And then we did the last one as difference of standard deviation. Now, single proportion. For this, whenever we are dealing with this kind of numerical, what you have to do, you have to read the statement, collect all the data, what is given to you in this statement. And then after analyzing your data, then you have to think if it is not mentioned in the statement that what you have to evaluate. In that case, you analyze your data and then we apply our formulas. Fine. And formula you know already. Now see, suppose you know the single proportion is given, then इसका standard error का formula. You just have to remember standard error का formula. बाकी सब आ जाएगा तुमको. Now single proportion is given, तो उसका standard error का formula is capital P, capital Q upon N. Similarly, standard error for difference of proportion का formula is डिफरेंस बोल रहा है, इट मींस दो होने चाहिए. प्रोपोर्शन का तुमको पता ही है, पी क्यू बाय एन का अंडर रूट. तो अभी डिफरेंस होगा तो इट मींस वी नीड 2. तो योर फॉर्मूला वुड बी व्हाट? P1 Q1 अपॉन N1. डिफरेंस है तो इट मींस डिफरेंस नहीं है, यहाँ बीच में प्लस है. P2 Q2 बाय N2. Now, single mean का formula is sigma over under root n. Difference, in the difference, your standard error is sigma 1 square by n1 plus sigma 2 square upon n2. And difference of standard deviation, we have sigma 1 square upon 2n1 plus sigma 2 square upon 2n2. Now, standard error तुमको पता चल गया, then how you are going to evaluate? Next, you need your Z statistic. The Z statistic for single proportion is small p minus capital P upon your standard error. Difference के लिए means small p वालों का difference, capital P वालों का difference. It means we will have P1 minus P2 minus capital P1 minus P2. लेकिन when you are establishing your null hypothesis, then इसके लिए 3 cases arises. Your first case is when your P1 is equals to P2. In that case, अगर P1 is equals to P2, ये क्या है? This is your null hypothesis. If P1 is equals to P2, अगर equal हो गया, तो it means what? Your this term is 0. Then your standard, your Z statistic, that is Z, this would be small p1 minus p2 upon standard error. Now, your second category. Your second category is when p1 is clearly not equals to p2. When this is not equal, it means sample ka proportion would be equal. In that case, we will have capital P1 minus capital P2 upon standard error. Standard error. It means we are taking as small p1 is equals to small p2. And your last category is when your population proportion is unknown. It is unknown. When it is unknown, then we have to find the unbiased estimator. Unbiased estimator. Now, how you evaluate that unbiased estimator? You remember the formula? Using the cap formula. Your capital P का cap equals to N1, P1, N2, P2 upon N1, N2 upon N1 plus N2. And your capital Q का cap is 1 minus capital P का cap. Fine. So, this is the formula for the difference of proportion that you have already done. Now, for the single mean, your Z statistic formula is X minus, that is mean of the sample minus mean of population upon your standard error. This is my Z. Now, this is your formula for single mean. Then difference of mean. Now, difference of mean would be again your X bar Z statistic minus mu upon your standard error. Now, again, three cases arises for difference of mean also. You remember? When we have difference of mean, it means again we have two kinds of samples. In that case, your first case is your variance. Sigma 1 square is what? It's a variance. It means when your variance of the population, that is sigma 1 square, is equal, say suppose they are equal, means the variance of both the population are equal. In that case, now you see your formula, this formula, this one. Now you see sigma 1 square, sigma 2 square both are equal. If both are equal, so sigma 1 or sigma 2 की जगह you are writing sigma square. So sigma square will be common. तो अगर ये common हो गया, तो you can write your statistic as ऊपर x1 bar minus x2 bar. Since we are evaluating the difference, so difference would be, इसको generalize में लिख लें, so this would be x1 bar minus x2 bar. ये था minus mu1 bar mu1 minus mu2. इनका subtract. So first we are considering that they both are equal. We are considering in the null hypothesis that the mean of the populations are equal. We are considering this. So difference of mean would be of sample only. That is x bar minus, this formula is reduced as x1 bar minus x2 bar upon your standard error. Now, your standard error ka formula would be dependent on the value of your variance. So, our first category would be when the variance are equal. When the variance are equal, then your this formula is replaced as, now you see sigma is common and this is square and it is under root के अंदर है. So, we will take sigma outside. So, we are left with 1 by n1 plus 1 by n2. Second case arises when your variance of the population, that is sigma 1 square or sigma 2 square are unknown. They are not given. And when they are not given, then in that case, we consider the variance of sample. So, your Z statistica formula would be your x1 bar minus x2 bar whole upon S1 square upon N1 plus S2 का square upon N2 और इसका whole under root. Fine. And your third category would be what? When the variance of the sample is unknown. Variance of the population, that is, variance of the population is completely unknown. Is completely unknown. That is the common variance. Is unknown. Then we find using the unbiased estimator. That is, sample का variance would be given. This is your N1 S1 square plus N2 S2 square upon N1 plus N2. N1 plus N2. So, your Z statistica formula would be x1 bar minus x2 bar S and under root N1, this is 1 by N1 plus 1 by N2. Fine. It's clear? Till here? These are our formulas. Now, say suppose after this, you have your another thing, that is your level of significance. Level of significance. Now, what is the value of your level of significance? That is your alpha for the two-tailed test, right or left tail test. For 1%, for 5%, and for 10%. For 10%. Now, if you remember the values, everyone? The two-tail test for the 1% के लिए you have value as 2.58 और अगर right your left लेते हो तो this is 2.33. Right के लिए positive और left के लिए negative. Then this would be your already know 5% we have value as 1.96 or if we have 1.645 left होगा तो it would be negative and 10 के लिए this is 0.645. You have to learn these values and your this value would be 1.28 positive, right के लिए left के लिए negative. If this is your level of significance, then what would be your confidence limit? Your confidence limit is opposite of level of significance. That is, अगर 1% का मतलब क्या है? Means my type 1 error is included here. Type 1 error, it means whatever solution is coming, so I know कि सिर्फ 1% type of error ही होगा. Type 1 error is included here. 5% means only 5% type 1 error है. या only 10% type 1 error. So confidence limit what? 1% में I am 99% confident कि इसमें error नहीं है. 5% level of significance means I am 95% confident that there is no error. And here I am 90% confident. Now how you are going to evaluate the limit? Say suppose proportion वाला question दे रखा है या category है, then your formula would be capital P plus minus your level of significance into your standard error. और standard error का formula is PQ by N. और अगर mean वाला category का है, then mean में here we will have mean that is x bar plus minus z alpha and mean का standard error is sigma by under root n. So you will have all these values. Now Z alpha would be what? 1% है तो 2.58, 5% है तो it will be 1.96. Right tail के लिए और two tail के लिए, if you are considering right tail test, तो Z alpha would be 2.331 के लिए, 5% के लिए it would be 1.645. ठीक है, तो proportion given है. अब से suppose population का proportion नहीं दे रखा है, then in that case confidence limit का formula would be small p plus minus Z alpha under root small p small q by n. This is our formula. So in sampling we have covered till here and we have done every kind of question from curve fitting also and from sampling also. We have done every single question based on all these formulas. Isn't it? अभी याद आ गया सारा कि नहीं? Revision. It's clear till here, everyone? Am I audible? कहाँ गए सारे? I'm not getting any response. Yuvraj. All right. Fine. So we are still left with 3 minutes. You want to do one question? We still have 4 minutes. No, 3 minutes. You want to do one question? All right. I'm clearing the board then. Suppose question is given as लिमिट का क्वेश्चन तो करा ही है. लिमिट का क्वेश्चन करते हैं. Suppose a sample is given. I'm writing in shortcut. Sample की value is 500 sample from the population. ठीक है? So these are the sample. Sample का size and mean is given to you as 70 and standard deviation of the population is given as 11. And they have asked you to find confidence limit at 5% level of significance. Find, this is your level of significance, alpha. Find the confidence limit. निकालो फटाफट. I have not written complete statement, shortcut में लिखिए value. Sample is given, X bar is given, sigma is given. And they have asked you your confidence limit. So you already know your confidence limit का formula. That is mean plus minus confidence limit के लिए your, this is level of significance. And this is sigma by under root n. तो सारी values put करनी है. 5% बोला है. So this would be what? 1.96. Substitute करो values और निकालो फटाफट. So whatever you will get, this is your confidence limit. कर लिया किसने? Done? Only 1 minute left. Less than 1 minute. आगे आंसर? ये कौन सा टाइम है एंटर करने का? यश गुप्ता. आया आंसर? Class will be over now. So your unit 2 is complete. In next lecture,